So this is like part two. We're gonna continue and finish our question. So now we have our chemical equilibrium equation, we have our formula, and we have our concentrations here. What's next is that we go back to our question paper. You're gonna check for the equilibrium constant. That's gonna be, in this case, our equilibrium constant is 3.76 times 10 to the exponent of -3. So since we have our equilibrium constant, we can now be able to find the initial number of moles of iodine molecules. And from that initial number of moles, we can be able to find our mass. So this is gonna be equal to we're gonna get our product here, which is square that so our product or is gonna be 2.29441 times 10 to the exponent of -5. So that's the concentration of our iodine gas, our iodine atoms. Sorry. So below this we have x minus 0.0294585, which is also divided by 12.3. So I'm sure you know that this is basically gonna be, let me just call this x. This is basically gonna be sorry, undo that. Let me just leave it like that. So through mathematics, you're gonna find out that this is okay. Firstly, let's just get rid of this. So this is divided by 1. This is gonna be multiplied to that, and this is gonna be multiplied to that. So from multiplication, we're gonna get 3.7 times 10 to the exponent -3 multiplied by -0.02952945585. So you're gonna have 3.79 or 76 times 10 to the exponent. Let me and this is gonna be into x minus 0.02945585. 3 is equal to, this is going to be divided by 12.3. (2.29441) times 10 to the exponent of -5. So you're gonna multiply this by this, and you're gonna multiply both sides by 12.3. So you no longer have 12.3 here. You're gonna have 12.3 there. And after that, to eliminate your 3.76 times 10 to the exponent -3, you're going to divide both sides by 3.7 times 10 to the exponent -3. So it's going to be somewhere down here. You're going to divide this, sorry. You're going to divide this and put it somewhere here. 3.76 times 10 to the exponent of -3. So now you're left with your x minus that. And in order to eliminate this, you add 0.0294585 on both sides. So at the end of the day, you're going to have this here added to 0.0294585. So I usually do this in order to avoid converting too much and my answer being a bit more off. So if you just type all of that into your calculator, you should be able to get the correct answer. 0.029455. You're gonna have so my answer is 0.1045149973 more. So this is actually, let's say you're almost there, but there's just one last step in order to get to the answer. So now the last step, you're gonna apply your formula where the number of moles is equal to the mass divided by the molar mass, which is mm. Sometimes it's mw, sometimes it's just capital letter M. So you're gonna, from this equation, when you're making mass the subject of the formula, your mass is gonna be equal to the number of moles and the molar mass. So we have a number of moles here as X, and we have to find our molar mass. So the number of moles, that's going to be 0.1045149973, and that's going to be multiplied by the molar mass of the iodine molecules. So that's going to be 2 times, you're going to go to your periodic table, which they've given you. And look for iodine. So the molar mass of iodine is 127. So we're just gonna multiply that by 127 and close our bracket. So you're gonna have 0.1045149973 into 2 times 127. So your final answer, your mass is gonna be 26.55 grams. So that's gonna be your final answer. That's the mass of iodine molecules that was used. So as you can see, this is a very long question. That's why it has 9 marks. So do you understand it, or did I lose you somewhere?
I think I understand it, sir.
Okay, so just remember to always convert everything into the number of moles before you use your stoichiometric ratios. And I think that's always gonna be the number one rule. When you see equations and you get a question and you feel like you are gonna use stoichiometric equations in that question, try your best to convert everything that you were given into the number of moles. So yeah, I think that's it. Do you need help with something else?
No, I think that's fine, sir. That was the only thing I was struggling a bit with.
Okay, so this was one of the more difficult questions. You're probably gonna get something easier, but usually the trial exam is harder than the final exam. So you might meet something like this now, but you won't meet it. It's less likely that